So welcome everybody, and I'm glad to be here, and I'm glad that PyData is happening in the Carolinas. Thanks to the organizers that did a wonderful job here. The GitHub repo for the tutorial, you can look it up afterwards, or you can also download it now if you want. You will not need it on the servers that you've been given. You'll be able to access it directly. So the URL for the GitHub repo is github.com/fdion/PyData. Alrighty. So just before we start, how many of you consider themselves data scientists? Okay. How many of you have built at least a linear regression model? Okay. So at least we'll be starting with that common ground. Maybe you have not, or maybe you've done web applications. Maybe you haven't, and that's fine. We'll get you up to speed. Don will do that. But as far as Python and doing web application, this is not something new at all. I don't know if anybody has a copy of this, Internet Programming with Python, written by Van Rossum and Waters and Alstom. 1996. So yes, Python and web applications is something very mature, right? In fact, if you have any doubt as to what it means, 1996, so to put things in perspective, that's 20 years. 20 years to put things in perspective visually. How would you have bought Star Wars at the store? Probably on VHS tape, or perhaps on Laserdisc, right? Okay, so that's been a long time, so it's mature. Don't worry about it. You'll be able to use it and scale it however you need to scale it. And so tonight, this morning, I mean, we'll be able to present this tutorial to help you go from 0 to launching a web application with a model and using Flask. And so we'll start with Don, and I'll cue him. Oh, well, no, actually, I'm sorry. Just before, making sure that everybody was able to access that screen. You've received a little paper? Yes? Okay, very good. You don't have one. Don, do you have an extra number that's left? Okay. So we spun up to the room capacity, so you can't share because you'll step on each other's toes. So anyway, and you have the password, you log in, you will get a screen that looks like this. And Don will guide you from there.
I will tell you, if you want to follow along, you'll notice that there's a PDS directory. And you can open that. We're going to start with the hello.py. So, thanks. So to start, we're going to build on what we already know. So take a look at these next couple of slides. This is pretty familiar to us, right? We have a client, in this case a browser, which is making a request, which goes to a server, and the server sends back a response. We're all pretty familiar with that. The key terms, of course, are client and server, request and response. We start with the URL in the browser. And the main thing that I want to point out to you is that there's a particular scheme or protocol, HTTP, which we're using. And of course, the host is where the web application lives. And the other important part is the path. And Francois gave me this nice little, yay, there we go. Just have to remember to use it. So the great thing about a protocol is that it allows us to communicate. And we can expect the client and the server to be able to talk with each other. When the client makes a response, the important part of that is, as we mentioned a moment ago, the path But it also has to tell something else to the server. And that's what kind of method to use. So in this case, it's making a GET request. Is this familiar to everybody? Yeah? Great. Seeing shaking heads. Good. So of course, when the server gets that request, and I'm not used to standing still, sorry. When the server gets that request, it takes some kind of action. In this case, it's returning hello world. Pretty simple, right? So we're going to build our first web app. There's a, we're going to edit a new file in the www/tutorial directory. Now, you have a choice. If you're familiar with Jupyter Notebook, which I'm sure you are, you can either edit it in the notebook, or if you want to get a terminal, you can go over to New, choose Terminal. Well, I don't like using this mouse. There we go. And you can use Vim from the command line if you're familiar with Vim. Or you can edit it in the, come on. Or you can go in the www directory. Everybody feel like you're where you're supposed to be? Raise your hand if you're not, because Daniel's available to walk around and Francois is also. So we're going to edit a new file called hello.py. Again, if you have any trouble, go ahead and flag down Francois or Daniel. And we're building a Flask web application. So the first thing that we do is, you're familiar with in Python, you're going to import some kind of module. So we're going to import from Flask, the Flask object. And the very next line is we're going to instantiate our Flask object. And we're just going to call it app for simplicity's sake. Of course, you can name it whatever you want. The Flask module takes the name, the Flask object takes either the name, dunder name, which is either the hello.py, hello, or main if you're calling it from the command line. But that, you don't have to worry about that actually. So, everybody got that? You can look at me, throw things at me, something. Again, that's one of the great reasons you can follow along with the PDF if you type slower than other folks. The next thing we want to do is we actually want to define a function which is going to return the simple string hello world. The great thing is when you're using Flask is it takes care of building the response. I mean, you're going to build the response, but it takes care of sending it back to the client in an appropriate manner according to that HTTP protocol. So this is pretty simple so far, right? Now, the key thing is, though, how do we tie this together, this function that's returning a simple string, to that path that we had earlier, the /hello? We actually have to add a route, what's called a route, another name for path. And so we use the decorator. I don't know how many of you are familiar with the decorator, but if you're not, it's okay. You don't have to understand how your car works in order to drive. You just have to know that you start it with the @ symbol and the app.route, and that's a decorator on this particular function. So it goes right above this function. So anytime the client makes a request to the route /hello, or that path, this function is going to execute. The final piece of the puzzle that we need for our application, the way that we're running it here this morning, is the if_name construct, which you probably have seen before if you've done much Python programming. And the important point here is that you've got the app.run. And so this is what's going to actually cause our web development server, our development server to run. The port is correct at 0.0.0. That's going to tell it to listen on all interfaces. And we want this very important keyword argument, debug equals true. That way, when you have some kind of problem, maybe it can't find a template or you have some other kind of runtime exception, you'll actually get that information. Good question. On the server, it's going to listen to any requests that are coming from externally. Does that make sense? Any other questions about that? How many folks are actually typing in? Great. Is the pace pretty good? Okay, fantastic. Once you do that, once you get that typed in, you're going to need to go to the terminal if you're already there, or if you didn't, you can go back to the Jupyter Notebook, and under that new menu on the top right-hand side, choose a terminal. Hang on a second. I forgot to put a slide in here. From the command line, you're going to have to change directories to the www/tutorial. How many of you are familiar with the command line and know how to change directories on there? All right, be sure and help your neighbor to change directories in the terminal to the www/tutorial. Do that. Oops. So once you're in the tutorial, you can cd cd to www/tutorial. I'm sorry, cd sandbox. /www/tutorial, if I could type. And then once you're there, you should see your hello.py. And from the command line, you can type what I have here, Python 3 space hello.py. That's going to actually cause the development server that comes with Flask. It's built into Flask to start running.
So just briefly, I think we had assumed more fluency with Jupyter, but basically if you want to create your hello.py from Jupyter, when you click on the directory www, then you can go new text file, rename it to hello.py, and then you can start typing your code there. Does that make sense? Let me show here screen. I go on www, new text file. Fortunately, I think we're taxing a little bit the Wi-Fi here.
Is there a way to get more instances? I feel like sometimes people get kicked off when other people.
No, I think it's the network, the Wi-Fi. So if anybody prefers to work on that locally, again, you can pull the GitHub repo on your local machine, assuming you have Jupyter and all these tools there. So it's thinking, there you go. File, rename, hello.py. And then you can start typing away. far as the GitHub, it's github.com/fdion/PyData. So what we'll do also is we will review a notebook with the linear regression for those that are already familiar with that. Then you can take that time to catch up and finish the hello.py. So.
All right, so after you do the Python 3 hello.py, hopefully it tells you that the server is listening and that it's running on port 5000. And so then in your browser, you should be able to go to HTTP, and for the 0.0.0, you're going to have to substitute the IP address that's where your Jupyter notebook is running. Makes sense? And then make sure you run it on connect to port 5000 with that :5000 and /hello. And surprise, surprise, what do you expect to see there? Francois? Hello.world, right? I mean, hello, comma, world. Okay, so hopefully, how many people had success? Yay! Now, if you've not have had success, we've had several different issues, like the browser insisting upon putting www in front of your address. Don't know what's up with that. So we're going to continue on. Now, what did we notice about that response, right? It was just a simple returning the string. That's a static response. But of course, when we're building web applications, we're more interested in something a little different. So take a look at this next one. And what you notice is that something different is happening, right? We've added something to the path, a name, and then instead of just getting back hello world, now we're getting back hello Sue, hello Don, hello Anna. So it's a dynamic response, right? And that's what we want to be able to build when we're doing web applications. In order to do that, one of the things that you very often want to do when you have a website and you have a particular look and feel, for example, to that website, you have a lot of the HTML that's going to stay the same from page to page to page, right? So what we want to be able to do then is we want to be able to template it. Just like if you were sending a letter to colleagues, but you want to personalize it and have it, dear and the colleague's name there, even though all the rest of the letter is the same, you want to customize it, you might make a template. So for templating, when you're using Flask, we use Jinja 2. So we have a notebook. If you'll go to the notebooks directory, Jinja 2 IPython notebook. If you click on the notebooks, and you can follow along this notebook. It's the Jinja 2 notebook. Right. Jinja 2 is a separate project from Flask, but Flask makes great use of it, and it simplifies a number of things for you when you're using Jinja 2. So anyway, as I was saying, it's a templating engine. All you have to do is have some simple text files which have some special Jinja 2 syntax. And the first thing, as I mentioned, when you were sending that letter to the colleague and you wanted to insert the name, so the first thing you're going to have in your template are variables. And the variables look just like this. Let's go full screen here. And they start with the braces, and then you'll have a variable name, and then close braces. And from the Jinja 2, sorry. to make this simple and just to be able to demonstrate what's happening without running it in a web application, I'm actually just going to import the template. This is not the way that you don't have to worry about this when you're running it from your web application, but I just want to be able to highlight the template that we're building, and you can see the hello and the braces, and our variable we decided to call it name. The braces aren't part of your output, but then you can use just your normal Python, right? I've got a list of names here. We're going to iterate over those names, and then I'm going to print that, and what happens? Shocking. You're going to be surprised. No, wait, you're not surprised. That's exactly what you expected, right? So, very simple concept, but allows you to do powerful things. Now, the thing about Jinja 2 is it also gives you some control structures, which allow you to have some logic in your templates. And as a template designer, this is very important, especially if you're building HTML and you want, say, list, for example. You don't want to type list after, li after li after li tags. Instead, you want to allow Instead, you want to allow the template engine to do that for you. And so we have these statements that are very simple syntax. Again, it starts with a brace and a percent sign. And again, as I mentioned, we have control structures in Jinja 2. So we're going to cover just a few of those. The if condition. And you might do something. You're going to execute a block of code in here, just like you would the block of code in an if conditional in Python. And then, very importantly, it has the end if so that you can tell where that control block ends. So I have another template here. And this time, we're going to have an if conditional. If there's a name, we're going to print that name. Otherwise, we're just going to default to the hello world. I see some heads shaking. Makes good sense. Fantastic. I'm going to execute that. So if I print that template, rendering the name guest, you're going to be shocked again. Oh, no, you're not. Of course, I wish it would come up on the screen. Hello, guest. If I render that template without passing the keyword argument to it, it simply prints hello world. Any questions about that? It's pretty straightforward, right? It also has, Jinja 2 also has for structure. And again, a very simple example. You're iterating over names. Now this time what we've done differently here, before we were letting the Python iterate. Correct? We're letting Python REPL. This time we're going to actually let the template engine loop over the names. So instead of passing it a single name each time, we're going to pass it a list of names. You can see the name equal names. And we're going to get our output, hello Sue, hello Don. All right, all very straightforward. The final thing that I want to highlight for you, Jinja 2 does have some other constructs, but these are the ones that you're going to use day in and day out. And this one is the block name and the end block control structure. What this allows us to do in Jinja 2 is inherit. Remember, the whole point of a template is to be able to have some boilerplate code in a parent, for example, and then in the child template, you're going to overwrite a section of, you're going to fill in a section of the parent template. How many of you have used templating in Microsoft Word or some other kind of, a few people? Great. So we're going to build our first template now. The great thing is this time you have an existing file. So if you'll go to the www.tutorial/templates directory, there you'll find a layout.html. And this is going to be our parent template. And inside of that template, how many of you are familiar with HTML? Yeah, pretty much everybody, right? How many of you have written HTML? Yeah, I'm sorry. So we're not going to go over the HTML. It's pretty standard stuff, right? But this is the stuff that we want to have included in every page. So instead, the main thing that I want to highlight for you is the block control structure that we had a moment ago. So when Jinja 2 renders our child template, the child template is going to connect and fill in this part, the block main. So this is the part that you need to add to the layout.html, the block main, and the end block. You'll notice that main here is what I called it. You choose the name that you want to reference. So some people choose content, body, any number of things that make sense for you. And that's important because, as you'll notice, I have another block up here for title. And so I simply named it 2 different names so that in the child template you can reference which space you're trying to fill. Now there's also a child template there, child.html. And in that template, we already have some other Jinja 2, which, hey, this looks familiar. We had this just a moment ago, right? It's exactly the same. Now we have to do 2 things here, right? Any guesses what the 2 things are? This is all we have right now in this template. What do we use in the parent template? Was that? Okay, yeah, we're going to eventually need a list of names for this, but think about, we were just looking at our parent template, and what did we add to our parent template? Yeah, well, 1 second on that. Yeah, we have to have the block, and then a gentleman in the back also, remind me to give you a prize later, the gentleman in the back also said that we need to inherit from our template. So those are the 2 things we're going to add to this file. We need to add the extends, and that's what tells Jinja 2, hey, this child template is a child template of our layout.html. And then the other thing is that we want to fill in all of this code in the parent template block main. Yeah. Yeah. If you can pull up that PDF. And remember, if you can pull up the PDF, maybe you can split windows. So you can have the PDF on the right side and the child.html on the left side. So anyway, we've tied our child HTML, our child template to our parent template. We've filled in part of the one of the blocks in the parent. So now we have to be able to use those templates, right? So there's an existing file, inherit.py, and the www tutorial directory, that's the parent of the templates directory. And this simple application looks very much like the first one that we did, our static application, but this time we're making it more dynamic. So the first thing that you'll notice is we've added a new function which we're importing, and that's the render template. And then finally, instead of returning our static string like we did earlier, we're returning that child template. The great thing about Flask when you're using it with Jinja 2 is that it knows where the templates are. It has some, there are a couple of different rules, but basically the way that we're running it, it knows that it can find this template in a templates directory which sits alongside our inherit.py file. So if you add those couple of lines to inherit.py, render template, and the render template function call, child.html, and that's what it's going to do. After you add those, you're going to have to go back to your terminal. And if your other Flask web application is still running, the original, and you'll just hit Control-C a couple of times, and that's going to kill it. And then you'll do Python 3 and inherit.py, and you probably can't see that, so I'm just going to put it back up here. Python 3 inherit.py. Oh, silly me, I forgot something. So what we did is that we forgot to pass a name in, right? So we're going to do one additional thing. We need to add a new route. So now we have two routes to which this function will respond. Flask will call our function whenever the client makes a request to either of these routes. And you'll notice we've added a keyword argument to our function, and we've also added keyword argument to the render template. So let's talk for just a moment about the route. What you're going to notice is that we have something special here. This is the Flask syntax for adding a variable to the path. So simply put the angled brackets around the name, the variable name. And so when the client calls that name with a name like Hello Sue, it's going to pass Sue as the value for the key name to the function hello. Now the awesome thing is about a Flask web application is it's just Python. So here, when we pass name, we can capitalize it just straight out of the standard library. And it's going to capitalize that name for us and pass it to the template as the name. And that's the name that we used in our template. Anybody have questions about that? And then if you go back to the command line and type Python 3 inherit.py, hopefully it all works. Oops. And you can visit the site and put whatever you want for me. And again, it needs to be on port 5000, and you substitute your the domain name for your 0.0.0 for your Jupyter notebook. These are very simple applications, but they demonstrate the various types of templating and control structures and the routes that you need in order to build a much more complicated application. Any questions so far? And now Francois is not in the room? There he is. And it's my turn to walk around. So flag me down. Thank you.
Alrighty, so I think possibly in the few cases where we had issues, there were two individuals on the same machine, so each writing over each other's changes. I'm sorry about that. Lesson for the future, give everybody a super complicated password that can be shared or something like that. So, alrighty. So if we look at the notebook here, so this is more familiar. You'll feel, you know, I think we pushed your comfort zone quite a bit here for the first part, but if you're a data scientist, notebooks is an environment you're familiar with. So if we go under notebooks, house valuation, PyData.Python notebook. Is the font size good enough, or I should bump this a little bit? Like this? Better? Yes? No? Yes? It is a little dim. Um, yeah, let's see. All right, better now? Okay. So you're probably used to importing things such as pandas, NumPy, things like that. We will first, well, we're condensing something that would have taken a lot longer where you are tasked with getting data. In this case, we just go and directly read it from a GitHub content here. And we end up with house prices. The price column is various prices. Now, as you see those prices, don't be surprised by them. This is Seattle. So yes, you could buy 3 houses in North Carolina for the average price of a house in Seattle. So if we look at some preliminary data wrangling or munging that we'll do, we'll just add a renovated indicator. We'll drop the date, and we have 21,000 records here with 21 features. So that's a lot of features. We probably wouldn't use all of them, but if we look at some of the feature, I would think that square footage would be a good indicator of price. What we're trying to build is a model that will, given some features, will give us an estimate of the house price that we could expect to pay or to sell it for. So the first thing I do, and tomorrow if you attend STEM graphic, you'll be able to learn a little bit more about stem and leaf plots in a graphical way. But if not, let's just look at the distribution of these 21,000 data points and see did I not run the first line? Yes. There you go. I think, again, pushing the network there a little bit. So as we look at this, it starts at 75,000. Actually, I got a pointer too. So $75,000 all the way to $7.7 million. That's our data set. Heavy here in the $300,000 to $400,000. And the median is actually at around 450 right here. So that gives us a little bit of an idea of what we're dealing with. So if we look at pair plots with Seaborn, I'm sure you've used those, we'll compare the price, square foot living, and the condition of the house should matter, right? And the lot, the square footage of the lot. So if we look at the resulting plots, we see, so first of all, price and square footage right here. We see there's at the lower end, yes, it's a good representation, but as we go further to larger and larger square footage, there's a lot of variation. So yeah, we'll use that, but caveat, it does vary quite a bit. So it'll be a good model for lower square footage and lower prices, but maybe not so much for higher prices and higher square footage. And so if we continue here, we'll look at, so again, the square footage, this is what I was explaining. We'll look at latitude and longitude because location in real estate, right, is important. And sure enough, we see that there's a peak right about here for the latitude, and if we look at the longitude, there's a peak here, which happened to be probably downtown Seattle, right? So if we convert that to distance from the center, which I already calculated that, so we wouldn't waste our time here, we end up with latitude and longitude from center, the delta, right? So if we plot this, we'll be able to see Sure enough, it's not linear, right? I mean, the closer you are to downtown, you know. But for the sake of this exercise, we're sticking with just the simple relationship here. And so I also want a data frame without the price for my model. Linear regression from scikit-learn, along with, so here's what I'm doing. I could have used train test split, and if you go further in the notebook, you'll see that I'm using that for the more advanced model. But here I'm just simply skipping over every other element of my data frame. So for my training set. And from a linear regression, what do we get? No? All right, we get an intercept and coefficients, right? And so if we were to look at the equation that we would represent this linear model with is something like linear intercept plus the first coefficient times the square footage times the, plus the second coefficient times the condition, because I trained on, right above, on square footage and condition. I wanted something simple right here. But how do I use this in a web application? If I were to just take this, these tree lines, although here I'm getting a result, here's the takeaway. If you're building something for a web application, it has to work standalone. And what I mean by that, if I create a new IPython notebook and I paste this, is it going to work? No. Why is that? Because I don't have my linear regression model. And so, since this is a very simple model, what I could do is just simply use the actual values, right? So I could do something like, let's go back to our intercept is this number. So we'll define a function. We'll define a function called ballpark estimator. It's a very simple estimator that will take square footage and condition. And we could even put our default value on it, which are the actual average, which I noted here from the pandas data frame that we had earlier, the describe function. So we can just pass as a default 2,080 square feet, that's the average. And so we define the function. That way it is reusable. So you're used to running a IPython notebook from beginning to the end. Here we're having to think about this is going to be deployed on a web application. So this is what the refactoring that needs to happen. Or even better, you always write your code like this, then you don't have to refactor it. In this case, because it's a simple model, I will do this. Return the intercept plus first coefficient. We'll just copy and paste. Of course, this would not be a good solution if we were training on multiple data sets, different cities, or training that every week, so on and so forth. That would be kind of painful to have. We probably won't have time, but in this notebook also you'll see how to do with a more advanced model or the same model by exporting your linear regression model to disk, persisting it, and then reloading it when you need it on your web application. Everybody following? Yes? Okay. The second coefficient and let's test this by calling ballpark estimator, and let's do a square footage of 2,000. Alrighty, so we got, for the average value earlier, we had gotten 541, but just by dropping 80 square feet, we're down to 518,000, which is still a good amount of money. So again, now that I have this, I could easily take this, go into a different notebook. This is the right way to test, right? Because now I know I don't have any other variables or anything like that. This is fresh. It works. Now I could go and take that and put it into my notebook. Were you going to demo that, Don, or? So we'll be a little brief on our presentation because else we'll run out of time. But
so we have a model. We got a function as a result of that. So now we're going to introduce you to a couple of new things. We're going to edit realestate.py in the www/tutorial directory, which will allow us to build another. Yeah. If you still have that other application running in the terminal, you can just Control-C to kill that. Here's the ballpark estimator that Francois just showed you a moment ago from the notebook. So you could really copy and paste. We're going to add that into our realestate.py. Anywhere you like, pretty much. Now, a couple of the things that I want to point out to you, though, that we've added to this realestate.py. We already have our Flask object and our render template function. Now we have a new object called request. Now, as you might guess, request is available whenever the client makes a request. It's very simple. However, in Python, this is a special object. It's a global object, and we're not going to go into what that means right at the moment, but the important thing for you to know is that, wait a minute, if we're going to be interacting with a user, and we're going to get them to enter things like square footage and conditions so that we can then return that value, we're going to need to have a web form, right? And so the request object has a form object, which then you can actually get the values out of it by simply using the keys from your form, in this case square foot and condition. So I wanted to highlight that. The other thing that we need to remember is in HTTP, there are different methods. We've been using the GET all along. But now when you introduce forms, you can also use the POST method. So now you have to be explicit in your route decorator, and you actually have to list out the methods for which this function will get called. By default, it listens for GET, so that's why we didn't have to add it the first time. But once you start getting more complicated, you'll need to add a list of methods that your function supports. There are other HTTP methods, but we're not going to need those for the purposes of this. And then all we need to do in our online, well, should be line 9, I believe, depending on how you're counting. If the request.method is equal to a post, then we know that the client has issued a post. Whoops. So the important thing that we need to think about now, that's all we need to add to our realestate.py for it to connect to the form. But now we actually need a form, right? We're not going to go very much over the form except to notice that it's using the post method, and then it has some inputs. One of them is called square feet. That's what corresponds to that request.form square feet, of course, call. And then we also have a condition, which is a select. It's just going to be a drop down with the condition. And then if you run Python 3 realestate.py after adding your function, then you should get the form and be able to input. Yeah, let me show the completed, sorry. That's great. Yeah, Where do you have it? Do you have it up? 22. Did you add it up? Oh, thanks. So just so we can glance. Work. So you can see the completed file where we added the request. We also added our methods to the route decorator. This is listening on the route. And we also passed in, just like before where we were passing in name to our function, now we're passing in square foot and condition. We check if the request.method is post, then we're going to get those values from the form. And then we're going to use our ballpark estimator, passing those to the function. And then when it returns it either way, we render a template. So the first time that this gets called is when the client makes a GET request. And so all that will happen is it will render the blank form. And then the next time that it gets called with the post request, it'll actually execute that conditional block, if, and fill in those values. So this is just an expanded version of what we were doing earlier. The only difference now is that we've added the request object so that we can actually find out things about the request that the client is making. Oops. So of course, we still have our if under name at the bottom. Any questions about what's happening here and how we've tied this to our form? No particularly quizzical looks, so I'll take that as a good sign. Of course, you can visit it at substituting your domain name, IP address, domain name for 0.0.0 and on port 1000 at the root path. So later on, when you have some time, free time between sessions or whatever, or the end of the day, if you're bored at the social, we have a couple of extra files in there that you can go and follow the instructions inside and get a little more practice. Back to Francois.
And again, it's possible that not every single file is actually on the GitHub repo yet. I think we've done a lot of this stuff. It was dark outside and we were a little tired, I think. However, today we'll make sure that all the missing files are uploaded if you're missing any of the demos or examples and stuff like that. So if we go back to our notebook, we just build our estimator, and I'll just briefly go through here. And if we score this, our CV score here is actually 0.48. This is good enough for a ballpark estimator. Of course, we could do better. If you're no doubt familiar with the RFE, the recursive feature elimination of scikit-learn. So you could run that and say, oh, okay, let's see what are the top 6 features that I could use here. And of all the columns, it actually decided the RFE support, and I passed that to the column names so I could see what they are. So it's going to be square foot living, which is the number 1 we had selected. Waterfront, we had conditioned, but here it says waterfront, and obviously this would impact tremendously if you're in front of the beach versus, you know, if you have the view of a great wall or something like that. Square footage above, square footage basement, latitude from center, longitude from center, which is good because we kind of had the feeling that location would be important. So what we could do here, so we'll do a training and test split with train test split. Train our model. We have a model, but in fact we can print, 67. So it would be a bit better. However, we do have to pass a lot more to our function. And our function is going to be a little more complicated. But also, I just wanted to take a moment to note here that what you might want to do is append to the model we just built. So LR, what did I just do? Code. So LR dot, let's say that we want to save that score. So we could add an attribute called CV equal LR score, X test, Y test. Anybody has a guess as to why I would save the score with my model? If I'm going to deploy that, maybe through an automation system, and I have a criteria of a minimum score that I want to use, I could automatically deploy new changes that are pushed to GitHub, for example, pulls it from GitHub, it runs, or it looks at the model that's being saved through the automation, or maybe it's trained only once and you're pushing just the trained model. Well, the trained model by itself doesn't tell you anything, right? I mean, you don't know when it was trained, you don't know how good it is or anything like that. But if I do this, and actually let's go further and do lr.version, it's random attributes. I mean, you can name them whatever you want, pretty much. Let's do a datetime dot today. And so now I've saved the moment at which it was trained and the CV score within my model. How would we call, or how do we, well, we need to save it at this point, right? Because this is not available outside. So how would I save it? Let's import from scikit-learn externals joblib. From sklearn external import, if I can spell, joblib. And with joblib, now I can do joblib.dump my linear regression model that I just trained, along with the extra attributes, and save that to a folder called train models lr.pkl. And what it did, it saved my train model along with the NumPy data that's associated with it into that train model folder. And so I could have something, let me open a terminal. No, CD. Notebooks. House validation. So I got my trained models that I just created here, and I wrote a little quick script. This would be about as simple as it would get for an actual deployment script, right, where you just copy. If you've pickled data, also you would do the same, but the trained model would be copied over. So if I run this, it actually copied over to my 3W directory. So this could be actually a SCP or something that's controlled by an automation or continuous integration, continuous deployment system. But again, it could also, instead of doing a copy or something like that, it could actually load the model with joblib, check the CV score, check the date, and if the date is wonky, maybe it's a year ago, maybe it will say, no, I can't load this, this is too old, or the CV score is 0.01, never mind, I don't want that, so on and so forth. So you can actually add other attributes that fit the bill for you, for your deployment. Make sense, everybody? All right. And so if I were to, let's go back to our notebook. How to call it. So the bad thing is we have 6 features that we need. The good thing is that even though some of them are kind of complicated. One is the geolocation, and if we are going to build a form, who knows their ICBM coordinates or the lat long where they live or the house that they want to buy? Nobody, right? So from a user experience, you will want to have an input of the address and then take the address and get the latitude and longitude. Fortunately, there's something called Nominatum, which is part of OpenStreetMap that you can use. And actually, it's one of the geocoders. There's other geocoders. I'm sure that there are people in the room that have their own solution at the company they work at. You can use that. It doesn't matter. GeoPy supports many geocoders. So we'll load the geocoders right here. So our better estimator, we looked at from a user experience, they will have to tell us the square footage still. Maybe a checkbox for waterfront. Are you in front of the beach or whatever? Below the grade square footage. If they give us the below grade square footage, then we already have the total square footage. We can calculate also the above grade. Pretty simple. And finally, the address, thanks to Nominatum, will get the latitude and longitude, but we also want really the latitude, longitude offset from the center we had calculated. Again, this is specific to Seattle, so you probably would want, and it's normal to actually build a model per large city like that versus perhaps in peripheral areas, you'll see that the same model holds across a much wider area, much greater area. So that makes sense here? So if we run this, let's see if it does work. Again, we define a function. We spent some time in the notebook making sure it works and, print better estimator. So I put a random address, 101 Main Street. It couldn't figure it out quite. It said, well, maybe you're wanting 15th Avenue Northwest. Probably not quite right. But if we'll actually show you the running application, and we'll try to put an address that actually exists in Seattle and see what happens. But at any rate, notice that this is 2,000 square feet, and earlier we ran and we got 518,000 or something like that. 652,000, just because this is in Seattle proper versus in outside of Seattle in peripheral areas. So the average, we see that we are much higher than the average here. And the last piece I wanted to touch on, beside creating more advanced models, and again, to export it would be, as we saw, fairly simple. We just use this here. Right? And so we can use it in our better estimator. And this is the line, the one line that calls, that loads the model back into the estimator, and the last line estimates it with the LR predict. And that should be familiar for those that are using scikit-learn and linear regression, or linear regression in general, in fact. So. Visualization, you're probably using maybe Matplotlib or one of the 17 other leading packages under Python. And if you want to know what they are, you can go to the GitHub repo on the README. There's a bunch of links to other libraries, visualization library. However, this would be probably how I would look at this. Maybe doing the residuals on both my training and my test set. The test set is in blue and it's plotted second, so I can see if they are overlapping or if they're very different. I might raise some questions, so on and so forth. And you can see this is not that great, right? I mean, actually we're going here. The variation is not symmetrical. It is, so there's a lot of heteroscedasticity going on here, but still it looks like it'd be usable in the middle, right? I mean, again, we only are using 6 features, and we just went with straight linear relationship. I mean, we could go a lot more complex, but for this exercise, I think that's sufficient. How do you get this visualization? Maybe your boss walks in and he says, "Oh, this looks pretty. I want to show that in the boardroom." Okay, I'll send you a PowerPoint. No, it's got to be on our commercial, external, accessible website, and it's something I want to demo to customers too. Are you sure? Yeah. All right, so how do we do that? We do that by using MPLD tree. So that's going to limit the amount of work we have to do here. I don't think we had imported it here. No, we hadn't. I'll bring it up. So while it's bringing it up, MPLD tree allows us to use Matplotlib or even Seaborn and publish that to the web as SVG. But it actually has a function that returns HTML that's ready to integrate with your template. And so the way we would do that, we don't just import Matplotlib, pyplot as PLT. Once we have actually installed with pip install MPLD tree, we are doing this here. So if I go back, I can go down, replace this. So that would be basically, it's not a big change, right? I mean, I'm just adding comma MPLD tree. And the other thing I will want to do, if I am exposing, if I am putting that on a web page, if I can find, okay, this tab. We also have to specify the render. Okay, so what's the default renderer with Matplotlib? It uses the X server on a Linux or Mac system, or actually one graphical system that has to be up and running. We don't have that on a web server. The web server is actually instantiated from a process. I mean, if you're in production, probably through something like Supervisor or something like that. So we don't have access to that backend, and so what we do is use an alternate backend that will work with the web, and that's AGG. So, so in the web application, I'm bringing up again because due to time we won't have time to actually type this stuff. So again, adding that at the beginning of my web application. Can you see that from the back? Yeah. Okay. So basically importing Matplotlib, saying use AGG, and then import the pyplot as PLT and MPLD tree. Now, if I go to my new method that I've added, my new function, an admin function with the metrics. So now, because my plot, because my plot actually use data from the test and train set, right? I mean, normally you wouldn't have that, you wouldn't publish that, you wouldn't use that into, but your boss said, yeah, do it. So you're doing it, right? So what I am doing here is simply just creating another folder called data, and I will pickle through the job lib again the well, I had done that on the notebook itself, and now I would have it available here as a X-test, Y-test, and X-train and a Y-train. So now I can actually run my plot scatter for my test and train set. But again, normally this is not a usual scenario, but this is a worst case scenario. I'm just showing you, you can handle even that worst case scenario, which is I need every single data point from the original data frame, or actually from the train model and the test and train in this case. And the last piece, as I'm using this MPL D3 fig to HTML, and I'm getting the figure itself from the ax that's returned from the plot call. Why am I doing that? Well, because I need HTML and not a PNG. I don't need a PDF. I want something interactive. Although I could have used a PNG or a PDF. And in this case, then it becomes a static server. You're just basically showing this exact same document every time. Here, it would actually change based on, if the data behind it changes, then the graphs will change. So that metric page always gets refreshed from if you have a deployment of a model every night, and then every following morning you can go and check, oh, what does it look like? In fact, what I'm doing here with metrics.html, it's a template. Let's open it. So let's make it a little bit bigger. So we're extending the layout again. We're defining a block. And in this block, main, I will have current model version is the variable lr.version. Remember, I said we should probably have the date in there, so we know when this model was trained, with a CV score of lr.cv. So again, that comes in handy, so at least I can refer to these values here. And then I insert my data viz. Now here I put safe, telling Jinja that it's okay to not touch the HTML that's being spit out. Else it'll try to escape it. It'll make it in such a way that it will not render in your web browser. So that's super important. You're saying, no, I know what I'm doing. This is actual SVG HTML. It's cool. Do it. And basically it will do it. And how about a demo then? Perhaps we can run this whole thing and see what do we have. If I can find my running terminal, this one. So real estate tree is the one that has both the advanced model and the metrics page. Oh, that's not what I wanted to do. And HTTP. So this would be the form for the more advanced model where we could put an address. I did say we'd check something out, right? So let's go to Google Maps here and see if we can find something. Seattle. How about, I don't know, a university. Seattle. Let's see what we can find. I'll just grab a random address here. See if we can. Okay, 401 Terry Avenue. We'll copy that, put that in the form, and let's say again 2000. Fortunately, because I have default and waterfront is a checkbox, and I'm pretty sure this is not a waterfront, I don't have to check that. I won't even specify the square feet below grade. I'll just see what happens here. So I submit. It'll call nominatum and should come back. Oh, not good. So I think we timed out here. I'm sorry? No, it'll default to 1. It says don't panic, but I'm panicking actually. Yeah, I don't see. Maybe we should have, well, 2000. Yeah, that should have worked. Let's try it again. Oh, yeah, it probably timed out. So we would have had to actually handle the timeout of the query to nominate him. And it's possible that I've reached my limit for the day too. Wow. Okay, this is even higher, 729,000. And the last thing we did was adding this metrics page, right? So the metrics page, what it does have is, first of all, it renders what it can right away, and then the SVG is actually, that's 21,000 data points. So if you actually want to do visualizations with that many data points, I'd probably suggest maybe also looking at other options that instead of using SVG, perhaps you want to use something like the Canvas or WebGL, and there's different libraries that will handle that. In fact, today I think there's a tutorial on Bokeh that will handle exactly that. So you'll want to check that out. And so here, because it's an interactive form, I can actually go and click on the zoom icon, zoom in, and again at 21,000 data point it's a little sluggish, but it'll get there eventually. There. So again, with the minimum effort, we went from a Jupyter notebook into an actual application that's up and running, that has an advanced model, that has a form, that has metrics and visualizations that you can share. Of course, this is just the beginning. You might say like, no, wait, this is good enough, ship it, right? No. Unfortunately not. There's security aspects that need to be handled. There's all kinds of other stuff. So you'll want to go back to our PyData GitHub repo on fdon/PyData and look at not just the basics and the machine learning, which you probably know already, and the visualization, which you probably know already. The further reading, there's a ton of lists, like the list of lists, or the awesome Flask list. You will want to look at that because it goes and talks about tutorials, courses, books, slides, videos, and all kinds of other fun stuff, including adding an admin tool and adding security, because you don't want to ship stuff without passwords and things like that, admin tools and things like that. So you'll have to do a lot of reading on that. However, I'll plug in another tool that I found very useful. It's called Cookie Cutter. If you've never used this, actually I use it to generate even script for deployment to the cloud. It's basically a template. So let's say you've done your application once. You're like, okay, this is what I want to reuse again and again. I just want to plug in a few variables. So you can use Cookie Cutter to do that, and it'll generate a new project every time. There's Cookie Cutter Flask, Flask 2, and Flask Foundation that you can look on GitHub, and you'll be able to generate these applications very quickly. And that is pretty much it, unless you have questions. Anybody has questions? We do have how many? What, like a minute? Oh, we have 5 minutes actually. So no? All right, everybody, you have 5 minutes more to go and have snacks then. I appreciate your time. Thank you.